Hello, today we want to talk about solving quadratic equations using completing the square method. Now, not every quadratic equation you come across will be solvable using the factorization method. And for those, you have other methods such as completing the square. Now, let's look at what a perfect square looks like. X plus a squared. Now, that's a perfect square. If we expand this, we'll have x squared plus 2ax plus a squared. Now, when we try to solve quadratic equations using the completing the square method, what we're trying to do is to get our quadratic equation from a form such as this into a neat, tidy, perfect square form such as this. And then we can take the square roots of both sides. Let's start with an example. Now, if we take a look at this example, x squared plus 8x plus 4 equals 0. Now, this is not a perfect square. So what we need to do is to get this quadratic equation in the perfect square form. Now, how do we do that? The first thing we need to do is to move the constant term here to the right side of the equation. And we can do that in this case by subtracting 4 from both sides. And so our equation becomes x squared plus 8x equals minus 4. Now what we have here is the form x squared 2ax, x squared 2ax. Now what we need to do to complete the square in this case is to add something here such that we have this to become a perfect square. Now what we need to add here is our a squared. But how do we know what the a squared is? We have an idea of what our a is from here, because we have a 2a equals 8. Now if this 2ax equals 8x, definitely 2a is equal to 8. So if 2a equals 8, therefore a equals 8 over 2. So what we need to do to add to complete the square on this side of the equation is to take the middle term here, which is 8, and divide it by 2. That gives us our a, and then we square it, because what we're trying to add is a squared. So if we do that, we have 8 divided by 2 squared. But whatever we do to this left side of the equation, we have to do to the right side of the equation as well. So we have to add the same thing to this side of the equation. 8 over 2 squared. So our new equation becomes x squared plus 8x plus 4 squared equals minus 4. We know this is 4 squared, so that's going to be equal to plus 16. Now we have a perfect square here. And this perfect square is equal to 12. So the next thing we have to do is to change the form of the perfect square here to a neat and tidy form like this. Now how do we do that? We do that by opening brackets. Then we take the first x here and write down our x. Then we take our sign here, which is a plus, and then we take our 4 from here. Not the squared, just the 4. We close our brackets and then we square it. So if you expand this, you're going to get this. This is equal to 12. Now the next thing we do is to look for the square root of both sides. Now if we look for the square root here, the square root cancels out the squared sign. So we're left with x plus 4 equals. Now on this side, if we have the square root of 9, this is going to be equal to plus or minus 3. And the reason that is if we have 3 squared, this is equal to 9. So also is minus 3 squared. So if we're looking for the square root of 9, we have no idea if it's going to be plus 3 or minus 3, because the square of both of them results into 9. So if you apply that here, this is going to be equal to plus or minus the square root of 12. So from here we can get the two solutions to this quadratic equation. And our solutions are going to be equal to x is equal to, if we subtract 4 from both sides of the equation here, we are left with x here, and this is going to be equal to minus 4 plus or minus the square root of 12. So our two solutions are either x is equal to minus 4 plus the square root of 12, or x is equal to minus 4 minus the square root of 12. So we have x is equal to minus 4. The square root of 12 is 3.464. Or x is equal to minus 4 minus 3.464. So either x is equal to minus 0.536 or x is equal to minus 7.464. Now those are the two solutions to the quadratic equation, and that's how we solve complex in the square method. So the first step is to move our constant term to this side, and then we take the middle term here, divide it by 2 and square it, and we add that to both sides of our equation. Then we write out our perfect square in a neat and tidy short perfect square form, such as this, and then we take the square root of both sides of our equation. And with the square root of the constant term on the right side, we have a plus and minus sign there. And that is how we split this into two solutions. So let's solve one more example using complex in the square method. So let's take a look at another example. Now the first thing we have to do, like we said before, is to move the constant term here to the right side of the equation. And to do that in this case, we have to add 5 to both sides of the equation. And so our new equation is going to be equal to x squared minus 6. This cancels out this, and 5 here. Now the next thing to do is to divide the middle term here by 2 and square it. So we have 6 divided by 2 all squared. We add that to both sides of the equation. 6 divided by 2 squared. So we have our equation to now be equal to x squared minus 6x plus 3 squared equals 5 plus 9. And this is going to be equal to 14. So now we can rewrite our perfect square in a tight and neat form. And to do that, we open our bracket. We take our x from here, which is x. We take the sign here, minus, and then we take our 3 from here, 3. And then we square it. This is equal 14. So now we can take the square root of both sides. And so if we do that, if we take the square root of this, the square root sign will cancel out the squared sign here. So we're left with x minus 3. And that's equal to plus or minus the square root of 14. So now x is equal to, if we add 3 to both sides here, this 3 cancels out this 3, so we're left with x on this side. And on the other side, we have 3 plus or minus the square root of 14. Now we can split this into our two solutions. That is either x is equal to 3 plus the square root of 14, or x is equal to 3 minus the square root of 14. Now the square root of 14 is 3.742. So x is equal to 3 plus 3.742. Or x is equal to 3 minus 3.742. So on one hand, we have that x is equal to 6.742. And on the other hand, we have that x is equal to minus 0.742. So these are the two solutions to our equation. So let's try an example where the coefficient of x squared is not equal to 1. Now the first thing we do is move the constant term to the right side of the equation. And we do that by adding 4 to both sides here. So our equation becomes 2x squared plus 7x equals 4. And before we go any further, we have to make sure that the coefficient of x squared here is equal to 1. And we do that by dividing through by 2. So our equation becomes 2 cancels out 2 here to leave us with x squared. This is 7 over 2x. And this 4 divided by 2 becomes 2. Now the next step is to add something to this term here to complete the square and make it a perfect square. Now we know that we do that by dividing the middle term here by 2, squaring that and adding it to both sides of the equation. So if we have 7 over 2 and we divide that by 2, what we're doing is saying 7 over 2 multiplying by half, and this becomes 7 over 4. So 7 over 2 divided by 2 results in 7 over 4 squared. And we add that to both sides of our equation, 7 over 4 squared. So our equation then becomes x squared plus 7 over 2x plus 7 over 4 squared equals 2 plus 7 squared is equal to 49 and 4 squared is equal to 16. If we solve this, we're going to have 81 over 16. So our equation then becomes x squared plus 7 over 2x plus 7 over 4 all squared equals 81 divided by 16. So the next step is to tighten up this and write this in a short perfect square form. And we do that by opening the bracket. We take our x from here, we take our sign from here, and then we take just the 7 over 4, we leave out the square, 7 over 4, close our bracket and square everything. And this is equal to 81 over 16. Now we find the square root of both sides. So if we do that, the square root sign cancels out the square sign here and we're left with x plus 7 over 4. And on this side, we have plus or minus. The square root of 81 becomes 9 and square root of 16 is 4. So we have plus or minus 9 over 4. So from here we can make x the solid to the formula. And if we do that, we have that x, by subtracting 7 over 4 from both sides of the equation, we have that 7 over 4 minus 7 over 4 plus or minus 9 over 4. So our two equations then become either x is equal to minus 7 over 4 plus 9 over 4, or x is equal to minus 7 over 4 minus 9 over 4. So for this side of the equation, we have a common denominator of 4. So that leaves us with minus 7 plus 9. And this is equal to 2 over 4. So we have half here. And on this side, we also have a common denominator 4. That leaves us with minus 7 minus 9. And that's minus 16 over 4. And that cancels out to minus 4. So our two solutions are either x is half or x is minus 4. And that's how we solve quadratic equations using completing the square method. So this is another example where the coefficient of x squared is also not equal to 1. And we solve it like we solved the last one. So the first thing is to move minus 1 to this side of the equation. So our equation becomes minus 5x squared plus 6x equals, if we add 1 to both sides of our equation, we have plus 1 on this side. Now the next step is to make sure that the coefficient of x squared here is equal to 1. And we do that by dividing through by minus 5. So our equation becomes minus 5 cancels our minus 5 here to leave us with x squared. This becomes minus 6 over 5x, and this becomes minus 1 over 5. So the next thing is to divide our middle term here by 2, square that, and add that to both sides of our equation. So if we have 6 over 5 and divide that by 2, what we have is 6 over 5 multiplied by half. And 2 here cancels out 6 to have 3. So we're left with 3 over 5. So 6 over 5 divided by 2 is equal to 3 over 5. So if we add 3 over 5 to both sides, the square of 3 over 5 to both sides of our equation, we have 3 over 5 here as well, squared. So our new equation, our equation becomes x squared minus 6 over 5x plus 3 over 5 squared equals minus 1 over 5 plus 9 over 25. Now if you solve this, you have 4 over 25. So we can then write our equation as x squared minus 6 over 5x plus 3 over 5 squared equals 4 over 25. So the next step is to write this expanded form into a tighter form of the perfect square. And we do that by opening our brackets. We bring our x down from here. We bring our sign from here, minus. And then we take only the 3 over 5 here. And we square all that. And that's equal to 4 over 25. So the next step is to find the square root of both sides. If we do that, our equation then becomes the square root sign cancels out the square sign here. So we have x over x minus 3 over 5. And that is equal to plus or minus the square root of 4 here is 2. And the square root of 25 is 5. So from here we can make x the square root of the formula by adding 3 over 5 to both sides of our equation. If we do that, we have that x is equal to 3 over 5 plus or minus 2 over 5. And with this, we can have our two solutions. So x is either equal to 3 over 5 plus 2 over 5, or x is equal to 3 over 5 minus 2 over 5. So if, for this side of our equation, we have a common denominator here, which leaves us with 3 plus 2, and that's 5 over 5. So x is equal to 1. On this side of our equation, we also have a common denominator of 5, which leaves us with 3 minus 2, which is 1 over 5. So our solutions are either x is equal to 1 or x is equal to 1 over 5. I hope that we've been able to make completing the square method easy and understandable. Please don't forget to subscribe to the channel. Thank you.